Hello and welcome to the first of my videos on A-level physics. Over the coming weeks I'll be going through what you'll be covering in the 2 years studying for your A-level physics. Now whether you're going to be sitting AS in year 1 and A2 in year 2 or following the straight 2-year course, my videos will give you an insight into what you will be doing. In addition to this, they're going to serve as a very good revision source as you progress through the course and particularly at examination time. Now remember, revision starts now after each lesson and it continues. It's not something that you suddenly start doing after the course content has been covered or even worse, right before the exams. Now please note that my videos are based on the AQA syllabus. That's what I teach at the moment, but that shouldn't make any difference to you if you're following, say, the OCR syllabus. After all, the physics is exactly the same, but there are some slight differences just in the way in which it's delivered. That being said, sit back, relax as we start off with this guide to what you can expect to discover over the next 2 years. Your school will have devised its own way of delivering the course to you. The chances are you'll have 2 teachers. One will cover about half the content, depending on the lesson split. So therefore it's very likely that you're going to be covering 2 topics at once. So one day you might be studying particles and then the next mechanics. Now year 1, or the AS year, consists of 4 topics. These are particles and radiation, waves and optics, mechanics, materials, and electricity. In year 2, or the A2 year, there are 3 compulsory topics, plus an additional topic of your choice. The 3 compulsory topics are further mechanics, thermal physics, fields, and nuclear physics. The options are quite diverse and are astrophysics, medical physics, engineering physics, turning points in physics, and electronics. You may find yourself studying 2 of these. If I were you, I would choose something I'm interested in or have a burning desire to learn in anticipation of that degree or career choice that you have in mind. By way of a quick heads up, you may not be taught things in the order that they appear in the syllabus or textbooks. For example, when I teach particles and waves, I leapfrog the wave-particle duality chapter and deal with this after I've covered the particles and the waves. I just feel it flows better that way, and it tends to make more sense. So before we deal with each of these in more detail, what can you expect in terms of the course itself? Well, firstly, I would be very surprised if your teachers at GCSE have not been saying things like what a difficult jump it is from GCSE to A-level. Indeed, I frequently find myself saying this. It is true. Having studied at all levels up to and including doctorate, I can honestly, truthfully say that this is the biggest jump you will have to manage. That's not to say that it's impossible, but it's just different. You'll find some of the content familiar, some of it completely new. You'll also discover some of what you were taught at GCSE, well, it's not quite right, even totally wrong. And that's not really surprising, as GCSE is really an introduction to physics and has, for reasons of understanding and brevity, has somewhat changed to allow the syllabus to run smoothly. That being said, it should not cause you any major issues. Now the key to exam success at A-level is similar to that at GCSE, but more magnified. Exam question practice is crucial. After all, even if you really understand the whole content, you still have to convince that examiner that you understand it. And I've seen many a student drop marks by not answering the question correctly. Reading those command words, understanding what it is you need to write and how it's every bit as important as writing good physics. If you answer a question in terms of forces, stating all the correct facts and details, you'll still score no marks if the question was expecting, say, an answer in terms of energy. When answering a mathematic question, always show you're working. If you grab your calculator and write in the answer just on its own and you get it wrong due to a sticky finger, you'll get 0. On the other hand, if you show the substitution, the rearranging, the calculation, and you still get it wrong, you'll get credit and possibly get 2, 3 out of 4 instead of nothing. Do this often enough and it will mean the difference between a good and a better grade, or even a pass or not. So finally, Keep on top of your homework or your prep, whatever you call it. If you fall behind, you'll be forever playing catch up. Plus, if you complete the work first, and then you can go off and do whatever you do for pleasure, you'll find it much more enjoyable without that little nagging voice at the back of your mind sitting on your shoulder there going, you haven't done this, you haven't done that. So when you're sitting down to play FIFA, Fortnite, or watch that movie or TV series, or go out with your friends, you can enjoy it more. Now, I'll see you in the next video where I'm going to start our adventure off with particles and radiation. We're going to find out that the proton, neutron and electron may not actually be the whole story of what's inside the atom. So until then, keep wondering about the universe.